Unit 18, Part 5, saying that we have a crucial piece of information in just following the rules, working backwards, doing the inverse of instantiation to get this, which resulted in A going in the second place in the two-place predicate L blank blank, right? That was crucial because getting through these proofs, completing these proofs, seeing how they go, a lot of it comes down to, I was saying, seeing how the y and the x, these variables in the two-place predicates, what instances those variables go to. Does the x go to A or B? Does the y go to A or B? Right? And you have to do quite a bit of working backwards often to see what you want. Because again, universal instantiations, right? We're going to do a UI on 1. We're going to do a UI on 2, which will result in a universal statement from which we'll UI. So we've got 1, 2, 3 UIs coming up, right? And which letter do we instantiate to? We're going to do some thinking about that, right? We've got to pay attention to what letters we want these things to be, and especially, not only, as we'll see in a second, but especially for the two-place predicates, and we've got a bit of information for that here. When we instantiate, whatever that is, which is the x, right? The L appears in second premise, just appears here. That's the only L predicate. Probably going to replace that x with an A, right? Okay, it's not the only place we match. Okay, so let's do UI on 1. Okay, so 5. I'm going to UI on 1. Okay, got to be replacing the x. Okay. Constant / variable, right? Both this was UG A / x, because I replaced the A with the variable x. Here I'm replacing the variable x, but with what constant? Okay, I have a choice. It could be A, it could be B. What do I want? Well, I want to be able to move forward in my proof. There's another instance of matching here, but here, what I want to match is what I'm attending to, which will determine what letter I write here, is that I want a PA, right? It's the one-place predicate, right? Okay, because the result of it is going to be P something hook. There exists a Y. The Y is going to stay in place. FY, right? So these blanks are where the X's were. So I'm replacing the x with what? I have a choice. I should replace it with A. Why should I replace it with A? Because there's a PA here and I want to do a modus ponens, right? I want to do a modus ponens, right? So that's what I see. I'm trying to get my formulas to match, right? And crucially, PA does not equal PB or PC, right? If Andrew is a person, that doesn't tell you anything about whether B blah blah is a person or a rock or anything else. Stupid, but PA doesn't equal PB is the point, right? So you have to this has to be PA to match this, such that this can be used with that conditional to do modus ponens, right? If you instantiate to anything else with an A, you can't do modus ponens using 4 and 5. This is going to result in a conditional. You need the antecedent of that conditional to do modus ponens, right? And the fact that this was PA sort of popped out of what was necessary as we work backwards, right? We figured out what the instance had to be to do this by UG, and that already put the A in place there as what is P. It's the individual A. Okay, so that becomes A. Of course, that means this becomes A, right? You're replacing every X with A. So it's FYA, right? FYA, so probably, right? I'm filling this in, is the F predicate, the two-place F predicate is what's going to combine 1 and 2. The two-place F predicate is in premise 1 and it's in premise 2, right? And I want them to match up. I want it to be the same instance, the same FYA, so that I can combine that information and make inferences, right? Okay, good. So we've got that. We modus ponens to this, which gives us an existential statement. F, Y, A, M, P, 4, 5. Okay, that's 6. Okay. So we've still got 2. Haven't done anything on 2 yet. We've got an existential statement here. Okay. We've also got an existential statement here. Could work backwards a little more. We could work forwards. Both of us are going to get us, both of these moves, forward from here or backwards from here, will give us sufficient information to get us home, basically. And by sufficient information, I mean specifically, it's going to give us the letters for the matching we need, okay? All right, because, okay, let's do this one. This is an existential statement. There exists a y, ly. Let me look at the consequent of 1. It's because that consequent is an existential statement. Is it ly? No, it's fy. Is there an existential combining the L predicate anywhere? No. The only place the L predicate appears in the premises is consequent here, right? With no quantifier above it, which means I'm not going to probably get this whole chunk, this whole formula as is by modus ponens, or anything like that. This doesn't appear as a this whole thing, this whole existential statement doesn't appear as a sub-formula in the premises, which means I'm probably going to have to use EG to get this. I'm probably have to do EG to this, right? So from what instance? Look now, doing the opposite of instantiating, EG is a non-flag rule, right? But what am I going to be replacing the Y with? It cannot be A. Why not? Because there is an A here. We've got L, Y, A. And if this Y was replacing an A, it would also replace this A. That's it. That's the statement. Right? It can't be LAA, because then doing the EG A for Y, this would be LYY. We need to get a formula which allows Y and A to be not identical, to be different objects. Okay? And the only way to do that is, well, it has to be not A, let's choose B. Right? The condition we need to satisfy is that it's a letter that isn't A. B is the obvious choice. So it's probably going to be L, B, A is going to be the instance from which I EG to this, which ends the conditional proof. I infer conditional proof, right? And then I UG from that instance. Okay, so look, LBA. So BA. So look, I'm filling in here. I said working that backwards was sufficient information to get me what I need. LBA. The only time L predicate here appears is there, and it's the LYX. So instantiating from 2, I know what to replace each of my variables with, right? I want the Y to go to B, I want the X to go to A, right? That's it. That's what I was looking for, that information. I want the Y to go to B and the X to go to A. Why do I want that? Because I want the LYX to become LBA. Working backwards, that was the instance I need. Now, see how I could have got that same sufficient information to get me home just using the rules going forward from here, right? This is an existential statement, right? So I can existentially instantiate, I can do EI on this, replacing Y with something. Can I replace it with A? No, I cannot existentially instantiate to A because whatever letter I instantiate to, I have to flag that letter. And I cannot flag A because A has already appeared in the proof. That's flag A. That was the very first non-premise step I made. That was the first step I made. Setting up for the UG subproof. All right, so I can't flag A, so I've got to flag B. This is a necessary step. This is determined. I'm saying the hard bit is resolving the choice for the undetermined steps, right, which is the universal instantiations, which you'll notice we did one, but we haven't done either of the 2 universal instantiations. We're going to do with 2. Yes. Okay, so this becomes F, B, A. Okay, so that's another bit of information. FBA, so again, so look how it matches. We want the y to go to b. It's FBA, so we want this y to go to b and the x to go to a. Yep, that agrees with the other thing we figured out. And FBA, that's gonna, yeah, okay. So, right, so that's, we all got all that from premise 1. Now it's time to universally instantiate on 2, right? And here is where I have worked my way to having my choice resolved in a good way. Okay, so UI on 2, so crank here. UI, sorry, it's B for Y. UI on 2 now, so I'm getting rid of X, and what am I replacing X with? So I want F. Okay, sorry, the result is for all Y, right? Universally instantiating on 2. What results? For all Y, brackets, so it's going to be a universal statement, F, Y, and I'm replacing the X with A, because I want FY, I want it FYA. I want this to become, right, FBA. And, so that matches, so hook LYA. Notice how this is doubly determined, right? What is doubly determined? That the so I instantiated from 2, I replaced X with what constant? A. It's doubly determined that it is doubly determined that I replace it with A rather than any other letter, Y. Why is it A that it's replacing it with? Because I want this FYA to eventually connect with FBA. There's an A in the second position here already, so that has to match that. And here, this has to match that. And here, A is in the second position of the L predicate, so I need A in the second position of the L predicate, which is what I'm replacing, right? It's the X that is becoming A, so it becomes that there. Okay? And now finally, okay, I now UI from this, so 3, 4, 5, 6, 7, 8, step 9, UI from 8, right? Okay, and now I'm getting F, so I'm replacing something, I'm replacing Y with something. What am I replacing Y with? B, okay? Y, B, hook, L, let's go. F, B, A, hook, L, B, A becomes this conditional. Why do I replace Y with B? Why is it B? Why am I replacing Y with B? In universally instantiating from this, because this is FBA, and I want this to be FBA, that's one match, and the second match is this, right? I want this to match that. Why do I want them to match? Because look, modus ponens. I want this to be the antecedent, and this to be the I want this to be the antecedent of the conditional that results, and this to be the consequent of the conditional results, and I make both of those things happen by replacing the Y with B. Putting a B there, this becomes that formula, that becomes that formula, thus modus ponens, these two get me to there, e.g. anoint the proof, and you're home.